Hi, we're going to look at the answers for the lab problems. I call these labs because when I teach this class live, I have the students get together in small groups and work on them together like a little lab peer group exercise. So here I'm still calling them lab exercises even though you're probably doing them on your own at home or wherever. So as a reminder, this isn't an assignment that you do for points. This isn't something that you complete and submit to me somehow. I simply am recommending a small number of problems here that you particularly take a look at and work through as good practice for the quizzes. It's sort of a little mini sample of the lecture. So it's just good practice. You should certainly do more homework on your own beyond what I suggest here. But these are really just sort of suggested homework problems to get you started. So let's jump in. Most of this is vocabulary oriented. So question number 2 basically says, define the terms population and sample and explain the role of each in a research study. Well, we know the population is the entire group of everyone we're interested in learning something about, the entire group of research interests to us, the group we're trying to answer some question about to better understand. So there are objective for understanding. The sample are the group of people taken from the population to participate in the study. So their role is to represent the population. Always bear in mind, our mission is not to understand the sample. Our mission is to use the sample to better understand the population they come from. So the sample is a means to an end, not the objective itself. Question 4 says, describe the terms statistic and parameter and explain how these terms are related to the concept of sampling error. Well, a parameter, I'll start with that one. A parameter is a value, usually numerical, that describes a population. A statistic is a value, usually numerical, that describes a sample. Notice those letters go together, by the way. P for parameter, P for population, S for both sample and statistic. So they're both values, usually numerical, meant to describe their associated groups, either population or sample. So what is sampling error? Remember that no sample is going to be perfect. All samples are going to have just natural imperfections in them, which means that no sample is going to perfectly represent the population that it comes from. So if we have a parameter that we know of for the population and we pull the sample out of there, we know that statistic isn't going to match exactly. If we know what the population mean is and we pull the sample out and measure them and get their mean, that remember that we won't get exactly the same value. There'll be some error in that. So sampling error is the difference, I believe your text says the natural difference, the expected difference that we would see between a statistic value, like a sample mean, and a population value, like a population mean. Question number 14. So this one, it tells us that we've got some researchers that have compared learning performance for students who studied material printed on paper versus students who studied the same material presented on a computer screen. All students were then given a test on the material and the researchers recorded the number of correct answers. So 14a asks us to identify the dependent variable. 14a is absolutely the trickiest question of the whole lab because the way the little story problem is written here, they're not very clear. They're not explicit about what the dependent variable is. So let's, to figure that out, let's back up a little step and think about the independent variable. It doesn't ask us for that, but that'll help. Remember, the independent variable is essentially the cause. It's the one that's being manipulated, the variable the researcher is manipulating. The treatment is what we often say in statistics, right? So what I mentioned in lecture videos is one of the ways you can tell which is the independent variable, one of the ways, is to say, hey, does this study have different groups? And if so, what are the differences between those groups? The differences basically are the treatment. The differences are the independent variables. So we've got one group of learners who are getting material on paper and another group of learners who are getting material on computer screens. So what's the difference? How the material is presented. So that's what the treatment is about. The treatment is about the presentation mode for this reading material? Is it given to you on paper or a computer screen? So let's think about it. If I, as a researcher, am giving one group of students material printed on paper, and the other group the same material but on a computer screen, what would I be interested in figuring out? What should the presentation method of the material, what difference should it make? What should they be better at or worse at? What should change about them? And the answer here, if we sort of think about it, seems to be, if you read it this way or read it that way, what should change is your ability to understand what you've read. So we could call this your reading ability or reading comprehension, but those words don't appear anywhere in the story. All it says in the very first sentence is learning performance. So technically that would be the answer. We want to know if the way material is presented changes your learning performance, changes how you're able to learn the material. So again, that one's worded a little bit tricky. I wouldn't word questions like that myself, but it's a good one to think through and to really have to puzzle it out. So our dependent variable is learning performance. Or again, we could have said reading ability if they'd have put it that way in the problem. B asks, are we measuring this learning performance as a discrete variable or continuous? Remember, discrete means that as we measure, our measurements are either this answer or that answer, this result or that result, but there's no in between. And remember, continuous means that there's essentially an infinite number of in-between options. So here, what they tell us is they gave an exam and that they recorded the number of correct answers. So they asked you a question. Did you get it correct? There's a point. Did you get it incorrect? No point. They're simply counting correct answers, which means we are working with a discrete variable. It's either correct or it's not. It's not sort of correct or partially wrong. It's either correct or it's not correct. So it is a discrete variable, separate, but no in-between values. Sometimes students say, but Paul, what about if they gave half points? Well, wouldn't 1.5 points be somewhere between 1 and 2? Sure, but first of all, don't write your own questions. It doesn't say anything about half points in there. This is a common hazard in this course. Students tend to want to add details in wrestling through the thinking through it. And as a result, they end up modifying the question or writing their own question, and they're not really answering the question that's being asked. Nowhere in there did they say they gave partial credit. But let's pretend for a minute they did. Okay, fine, partial credit. So if it's truly going to be continuous, remember it's basically an infinite number of in-between options. So would they give a half credit for an answer? That could happen. That happens in some classes. That'll happen for some things here. If you get an answer right, but let's say you don't round it correctly, that might cost you half a point. But what about 1/10 of a point? What about 100th of a point? Do you really think these researchers are scoring reading comprehension questions down to the billionth of a point? No, that's silly, right? So it is absolutely discrete. Now we want to know, is it nominal, ordinal, interval, or ratio? To be nominal, all we have to have are different measurement results. So let's say you take this test and you get 10 points and I take the same one and I get 8 points. 10 is a different word than 8. That's all it's got to be nominal, is that we can get different answers. What does ordinal have that nominal doesn't? Order, ranking, more and less. If you got 10 and I got 8, do we know who got more correct? Do we know who got less correct? Absolutely. The person with the score of 10 got more correct than the person with 8. So now what does interval have that ordinal doesn't? Well, interval has known distances. Do we know how much more or how much less? Again, if you have 10 and I have 8, we know exactly you got 2 more than me. We know exactly how much more. And then lastly, just check, could we push it all the way to ratio? And notice I'm taking it one level, one step at a time. That's exactly how I recommend you do this, unless you're really very familiar with it. Start at nominal and say, okay, what would it have to get to the next level? If it can't, stop where you are. If can, keep moving through like we are. So ratio says we've got a true 0. That if we record an answer of 0, if we measure a value of 0, it truly, literally means nothing was there. So if you took this exam and got a score of 0, it means you got 0 questions correct. And it means that literally, you truly got no correct answers on this exam. Now again, that can sometimes be a little tricky. Students end up kind of chasing themselves in circles with it. Remember, the other way to think about this is, could you get a raw score less than 0? If so, you were at the interval level, because if it's a true 0, you can't get any lower than 0. 0 is the least amount you can have if it's a true 0. So the question then to check is, could you take this exam and get a negative score? No. You either get a question correct or you don't. It's either a point or it's nothing. So that lets us know that we are at the ratio level. We have different names. Those names are ordered or ranked. We know the distances between them, and you can't have a negative score on this. So we have a ratio level measurement. Lastly, 18 ABCD, just some basic calculations using this data here. So 18A asks for the summation of the raw scores. So you literally just add the raw scores together, right? 3 plus 2 plus 4 plus 2, and that should give you an answer of 11 points. 18B is going to give us a little bit more to think about for our order of operations. So remember, just take it one step at a time. The first thing it says to do is what's in the parentheses. In the parentheses, it says to sum up your raw scores. Well, we've already done that. We know that's 11. And then it says square that summation. So 11 squared is 121. 18C says to get the summation of all the raw scores for the variable x, and then subtract 2 from that summation. So summing up all the raw scores for variable x again gives us 11. 11 minus 2 is 9. And then lastly, 18D takes this idea but puts some parentheses in it. Again, just take it one order of operation at a time, one step at a time. Inside the parentheses is where we start. And it says take 2 off of all the raw scores. So I have to subtract 2 points off of all of the raw scores. So 3 minus 2 is 1, 2 minus 2 is 0, 4 minus 2 is 2, 2 minus 2 is 0. And then it says, well, now sum up all those adjusted raw scores. So 1 plus 0 plus 2 plus 0 gives us a grand total of 3 points. All right, class, that is the lab from chapter 1. Again, I recommend you dive deeper into the homework problems to really, until you know that you feel confident that you can demonstrate your knowledge on quizzes and exams, just keep practicing on it. All right, we'll see you for chapter 2.